Assalamu alaikum. Let's start the lecture 2 regarding current electricity. In lecture 1 we have discussed about Ohm's law and EMF, electromotive force, and today we are going to discuss about different kinds of circuit, and in addition we will discuss about a tail of short. Short line is a particular line which always used in a circuit. We will discuss about that short line. So let's start today's lecture. Okay. Before starting, I have a question for you all. How many types of circuit do we have? Okay. Many among you can say that there are basically three types of circuit: series, parallel, and mixed. Some among you can also say that there are actually two types of circuit: series and only parallel. So what will I say? I always say that there are two types of circuit. One is series and another one is parallel. So what about this mixed circuit? Let's forget about mixed circuit, because as I am saying that there are two types of circuit. Erase it up. Number one is the series circuit and number two is the parallel circuit. So where that mixed circuit gone? So I will show you that there is nothing called mixed circuit. Actually those mixed circuits are the part of either series or parallel circuit. How? I am going to discuss it now. Wait. As I already said that there are two types of circuits, series and parallel. Each type has two types more. And what are they? Series are divided into two parts. Number one is simple series circuit, simple series. And number two is mainly series circuit. Similarly, parallel has two types. Number one, simple parallel. And number two are the mainly parallel. So basically, this series circuit which we know from our secondary level is our simple series, and the parallel circuits which we know from our secondary level are basically simple parallel. And the circuit we know about the mixed circuits are either mainly series or mainly parallel. I will discuss in details here in this lecture. Let's start with the simple series circuit. I already told you that simple series are the circuits which we know as the series circuits. So there are three circuits. This is the number one. As you can see that there are three resistance, 1, 2 and 3, and all these three are connected one by one after one. So this one end point, starting point of the 2 end point, starting point of the 3, and 3 end point. So this starting point of the other is connected with the end point of the previous. So one by one they are connected, so they are actually in a single line. They are in a single line. They are in a single line. One line, thousands of resistors, doesn't matter. They are in series. Okay, this is another circuit which is also simple series circuit. Now you can see that there are also three resistors, 1, 2, and we have here another one, 3. Now some of you can say that as these two are one by one, resistance 1 is the top and resistance 3 at the bottom of the line, so these two may be parallel. But please see carefully. If this is the cell, so electrons start from here, move through 3, 1 and then 2. So these 3, 1 and 2 are in the same line. They can be top, bottom, right, left, doesn't matter. If they are in the same line, so they are part of series. So as 3, 1 and 2, they are the part of the same line, so they are in series. It's a simple series circuit. Here we have another circuit. Now we can say that this shouldn't be a series circuit. Why? Because we have two lines parallel. But now here comes the most important thing. These lines, obviously these two lines are parallel, but we have to consider about resistance, whether they parallel or series. So here this line excludes any resistance. This line is known as short line. So when the current starts flowing from here, it moves through number 1. When current reaches here, it sees that there are two lines, one moving through the resistance and another one there is no resistance. So all electron will move through this resistorless wire, and through 2 it will return back to the cell. So the path of the current is, so that's the path. So though we have a resistance here, this resistance will not work into the circuit. This resistance. This line is known as the short line. At the end of this lecture, I will discuss about short line. So this is a simple series circuit. Here we have two examples of simple parallel circuit. You all are familiar about this circuit. So here we have two resistors, 1 and 2, and if you see closely, the starting point of both resistors, either 2 or 1, this point A, and the ending point of both these two is B. So starting point and ending point of both resistors are same. So they are mutually parallel. So this is a very simple parallel circuit. This is also a simple parallel circuit. How? There are two resistors. Electron start from the cell, reaches here and divide. Suppose this is the A. By this line, it reaches resistance 1, and by this line, it reaches resistance 2. So both resistance 1 and resistance 2 starts from point A, and the current through 1 ends at here and the current through 2 ends at here. So both 1 and 2, their end points are B. So both starts from A and ends at B. So these two are in parallel. So this is the simple parallel. Let's start discussing about mainly series circuit. If you look at this circuit, here, this is the mainly series circuit. Obviously you know it as a mixed circuit. We have R1 in series and we have R2 and R3 in parallel. So we have a parallel here. So why this circuit is a series circuit? So if you want to solve this circuit and if I ask you to get the equivalent resistance, then what will you do? At first, you will get an equivalent resistance of these two R2 and R3. Go for the parallel. You will calculate Rp, and then after that the circuit will look like this. Then you will go for R1 and Rp as series. So at first we'll go for the equivalent combination for this parallel, and finally we go for the equivalent combination for series. So initially we'll go for the parallel and then we'll go for the series. So finally this will be our circuit. Look at the circuit. What types it looks? It looks like a series. So finally the look of the circuit will give us the idea about whether it is a mainly series or mainly parallel. Finally it looks like a series circuit. So this circuit is mainly series, though it's a mix, but it's mainly series. So let's discuss about mainly parallel. This is also a mixed circuit. Here we have R1 and R2 in the same line series, and with these two we have R3 in parallel. So here this circuit, if you go for solving this circuit and go for the equivalent resistance, what will you do? Initially you go for the series combination of R1 and R2 and will get RS, and then finally with this RS you will take R3 as a parallel and go for the parallel combination. So what will you do at the end? Finally you will go for parallel combination. Initially series and finally parallel. So finally our circuit will look like this. Look at this circuit. What types it looks? It looks like a simple parallel. So finally what we do, or how our circuit look like, it will give us the idea about whether it is a series or parallel. If finally it look like a series circuit, then this mixed circuit is mainly series. And if finally it looks like a parallel circuit, then this mixed circuit is known as mainly parallel. I hope you get it. Let's start the tale of short lines. Short line টা কি? এখানে তোমরা দুইটা Let's start the tale of short line. So what actually short line is? Let me remind you, as I've already told you, these short lines are very, very important. Okay. Here you can see that we have two circuits. One is the main simple series and another one is the simple parallel. So let's start with the simple. So here current will start from the cell, it will move through 1 and 2, then return back to the cell. If I connect a wire like this, then what will happen? Current will start from here. We always know that current starts from the positive side. That's the positive side. So current will start from here, and when current reaches here, current will see that there are two lines. There's a one line which is moving through resistance 2, and this is the other line which is moving through a resistance-less wire or line. And both lines ended at a point, and there are no other resistors in the circuit. So what will current do after reaching here? If these two lines consist two resistance, then obviously this should be a parallel and the current will move through both lines. But when current reaches here, it sees there's one resistance included line and another one resistance excluded line. So what are resistance? These are like obstacle, problem. So let me tell you about an analogy, an example. Suppose you are a driver and at a certain time while driving you reaches a particular point and there are two roads and both road has a signboard showing that the road number 1, and it says that it moves through a jungle, and that jungle the road is too bad and that jungle is full of animals. There are wild elephants, there are tigers, and even there are hijackers, and they will take everything from you, obviously, certain, and they will kill you, and there are another sorts of different problems. There's the line number 1, road number 1, and if you move through the other road, it says that it's a expressway, like very smooth road, and there are different checkpoints where the people will give you free food, free drinks. There are cheerleaders, those will recreate you by using their pom-pom. So both line ends at a particular point. Both road ends at a particular point. So which road you will choose? And obviously if you are not mad, and obviously if you do not have problem, then obviously you will not go through the road which moves through the jungle. You will obviously take the expressway because that's smooth and that's problematic. We don't want problem. So like us, this line, while it has a resistance, this is the problem line, just like the jungle path. and this line, while we do not have any resistance, this is like the expressway. So when electron reaches at this point, all electron moves through this line where no resistance included. This line is known as short line. This line is known as short line. And when short line appears, the circuit will think that there is no resistance. So though you can see there is a resistance, but actually it will not work. So it will not work into the circuit. So this circuit has now only one resistance, and that's R1. Okay? So I hope you understand about the short. So look at this circuit. Here we have a parallel group. We have two parallel resistors, 1 and 2. So when electron reaches at this point, it divides into two paths. Resistance, some will move through the resistance 2 and some will move through the resistance 1. That's obvious. Because both line includes resistance. So as both line includes resistance, both line has problem. No matter electron will move, they will divide and move through this both line. So this is the parallel. But what if I add a line like this? Then what will happen? This excludes resistance. So when electron reaches here, the starting point, it sees that there are three lines. One has a resistance problem, another one has another resistance problem, and the third one, it doesn't have any resistance, right? So all electron will move through this line. No electron will go through resistance 2 and no electron will go through resistance 1. So though the circuit has two resistance, if you see, but none of them will work. So this will be the new look of the circuit. So it's a short line. And now let's think about this third circuit. These types of circuit once appears into board problem. So as you can see that there are two resistors in parallel and with one it's in series. So it's a mainly series circuit because initially we go for the parallel and at the end we go for the series. What if we connect this point? It's a short line. So when current moves through these two parallel line and reaches here, there are two lines. This is the one and this is the two line, second line. The first line includes a resistance and the second line, it doesn't include any resistance. So all current will move through the second line. So the first line will not work and circuit will look like this. So short line can exclude or it can omit a resistance or more than one resistance from a circuit. I hope you have got the idea about the short. And one more important thing. This was the look of the first circuit, right? So obviously these two are different points and the potential of these 2 points are different because we have a resistance here. But once you use a short line, then this resistance will not work. So these 2 points will be same. So short line makes the similar points. A and B both are the same points. Okay? I hope you have got the idea about the tail of short lines, and gradually there are different kinds of shorts and there are some circuits where some lines look like short but are not actually shorts. We'll discuss about those lines later. So for small problems, small circuit problems like whatever actually appears in your board exams, I hope these amounts of knowledge is enough for you. Okay? And I will give you some SW. That's the end of the now. I'm at the end of the lecture. I will give you some SW, and please do SWs, and the next lecture, that means lecture 3, we'll discuss about the series circuit, whether it's a mainly series or parallel doesn't matter. we'll discuss about series circuit, how to solve the series circuit, what types of problems appears, and we'll discuss about a very important law which actually records for series circuit, and that law is known as the voltage divide law. So next class we'll discuss about the series circuit, regarded problems, and voltage divide law. Thank you. Please share these videos with your friends of our college and the other colleges, because if they want, they can take help from these lectures. Thank you. Allah Hafiz.